For more than 5,500 years, people in Southern Europe and the Middle East have been making charcoal. The process they used can be considered pyrolysis. This process is the first step in combustion and gasification processes. Pyrolysis is one of the technologies used to convert biomass into energy using heat. Recently, fast pyrolysis is regarded as a promising thermochemical method for producing renewable fuels and chemicals from biomass and waste feedstocks. There are close to 100 fast pyrolysis projects in progress, and 10 commercial-scale plants have either been built or are under construction. After many years of development, biomass pyrolysis is maturing as a commercial technology. Pyrolysis is the thermal decomposition of organic materials occurring in the absence of oxygen. The word is derived from the Greek words pyro, meaning fire, and lysis, meaning breaking materials down into small parts. Pyrolysis of biomass is typically carried out within a temperature range of 250 to 600 degrees Celsius. The three main products are carbon-rich solid, a condensed liquid phase, and non-condensable gases such as carbon monoxide, carbon dioxide, methane, and hydrogen. The main differences between pyrolysis and the other two typical thermochemical processes, gasification and combustion, are: pyrolysis is a process that occurs in the absence of oxygen. Combustion requires that the amount of oxygen is sufficient to allow the complete oxidation of biomass. Gasification is regarded as being between pyrolysis and combustion in that it involves the partial oxidation of a substance. The main products of pyrolysis are liquids and solids. The main product of combustion is heat, and the main product of gasification is gas. Depending on temperature, vapor-solid residence time, and heating rate, the pyrolysis process can be classified as slow, intermediate, or fast pyrolysis. The main product of slow pyrolysis is a carbon-rich solid. The heating rate is slow that allows sufficient time for repolymerization reactions to maximize the solid yields. This slow pyrolysis is used to make charcoal for our barbecues. In the past 40 years, fast pyrolysis liquids are candidate combustion fuels for electricity and heat production in boilers, furnaces, and combustors. Transportation liquid fuels can be produced when the pyrolysis liquids are upgraded. Combustible syngas and hydrogen can be produced through steam reforming and gasification. In addition, pyrolysis liquids can be used as a feedstock for the production of chemicals. The carbon-rich solid can be used as a substitute for coal for the filtration and absorption of organic and inorganic pollutants, and as soil amendments. Pyrolysis gas can be used for the production of heat or electricity. It can be used for pre-treatment, drying, or can be returned to the pyrolysis reactor as a carrier gas. Pyrolysis is a simple process that can be performed on a relatively small scale and at remote locations by using a wide range of biomass feedstocks. Pyrolysis increases the energy density of biomass. Pyrolysis oil has an energy density that can be 5 times higher than biomass. Therefore, it can be easily and economically transported and stored, thereby decoupling the handling of solid biomass from utilization. Pyrolysis has the potential to supply a number of valuable chemicals that offer the attraction of much higher added value than fuels. A few European examples of pyrolysis are Pyro from the company of BTG in the Netherlands, Karlsruhe Institute Technology in Germany, Photon from VTT in Finland. The challenges of fast pyrolysis are the properties of the pyrolysis liquids are very different from conventional petroleum-derived fuels and require significant upgrading before they can be used as transportation fuels. In conclusion, pyrolysis is a thermal decomposition process occurring in the absence of oxygen. The main products of pyrolysis are a carbon-rich solid, liquid, and gases. Temperature, heating rate, and solid vapor residence time influence both the quantity and the quality of the products. Compared with other technologies, pyrolysis has the advantages of energy densification, easy transportation, simplicity, being easily performed locally, and a source of valuable chemicals. Pyrolysis liquids can be used in areas of heat and power, transportation fuels, and material and chemical products. For a wider application of the products, new separation and upgrading techniques should be developed